everybody, welcome back. Today we're going to talk about exponential growth and story problems that have to do that. With that, and again, we have our graphing calculator up. We're going to be recording here, so make sure that you pause when I tell you to, just so you can make sure that you get all the practice that you need. Our objective today is to be able to solve problems involving exponential growth and compound interest. So before we start, we have to make sure that we are able to convert percents to decimals. And the reason for that is in order to use percents, or as we call them rates in these problems, in an exponential function, we must first convert these to a decimal. So when we do this, this is kind of review. What we're going to do is you're going to take this number, which is 35.0. You actually, for a decimal, you move the decimal place over 2 points. And that is what it is as a decimal, because it's 0.35. So for 20, we would do the same thing. This is actually 20.0. Move the decimal over twice. It would be 0.20, or just 0.2. For 8, it's 8.0, so when I move it over 2, it's 1, 2. It's right here, and there's actually another 0 right here. So this is actually 0.08. So take a couple minutes, pause the video, go through and do 9.1%, 5.67%, and 0.1%. Alright, so we're back at this, and when we had 9.1%, we had 0.091. 5.67% was 0.0567, and 0.1% is actually 0.001. So once we're able to do that, we can start talking about these exponential growth functions. And our parent function for this, or our general equation, is going to be y equals a times 1 plus r to the power of t. And this is something that you're going to want to memorize when we go through these problems. An exponential growth is when you have an initial amount, which is our a value, so a is our initial amount, that increases at a steady rate, or our r value, which is a percent that we've turned into a decimal, or the rate that they give us, over time, which is t. And most of the time we say that time is years, but depending on the problem, it doesn't have to be. And then y is just the final amount that we get for that problem. Make sure that you, again, have this memorized, understand what it means, because we're going to go through and plug these in and use them in our equation. So our first question says, you bought a sculpture in 2004 for $380. It increases in value by 8% each year. What will the value of that sculpture be in 2012? I know that this is going to be an exponential growth problem because of this word increase, and it's increasing at a steady rate of 8 years. So that means I'm going to use the equation y equals a times 1 plus r, because I'm adding the rate since it's growth, raised to the power of t. So I have to figure out what some of these variables are. I don't know what y is. I need to figure out what a is, r, and t. And I'm going to figure out what each of these are equal to for this problem before I plug in. So reading the information above, again, I'm trying to find out my final amount, so I don't know what y is equal to. A is my initial amount, and it says I bought the sculpture in 2004 for $380, so that's what we're going to say our A value is. So we're starting off with this $380. That's how much we paid for this sculpture. R is our rate, which is 8%. However, I don't want it to be a percent. I need to make this into a decimal, which is what we started this lesson doing. So I'm going to make this instead 0.08, because I moved the decimal over twice. And time. Time, we're not going to put 2012. It's the amount of years that have gone by. So we're actually going to say that it's 8 years that have gone by, because there are 8 years between 2012 and 2004. So we're able to get all of that information just from those 3 short sentences. So I plug this information in. Again, I don't know what y is. My A value is $380. That's my initial amount. Then I'm adding my rate, which is 0.08. I'm going to raise it to the power of 8. And I can simplify this a little bit to start. I'm going to use my calculator to help me, and I'm going to clear this out. I'm going to do 1 plus 0.08, so I'm following order of operations. And it gives me that 1.08. So if I'm just looking for a simplified equation, it would be y equals 380 times 1.08 raised to the power of 8. And again, when I follow order of operations, all I have to do on the calculator is raise this to the power of 8, and I hit enter. Oops, delete that. Hit enter, and I get 1.85093021, which is a really long, crazy number. And I want my answer to be exact, so I'm going to leave that right there, and I'm going to multiply this by 380. Oops, not 81, 80. And I get the 703.3534799. And this is money. Money we always round to the nearest cent because it's how we spend. So we're going to say that this sculpture is going to cost us $703.35. And we round down because 3 right here is less than 5, so we don't round it up. And it's just 5 or more we round up, below 5 we round down. So this statue is going to be worth $703.35. Okay, we're going to do the same thing, but I'm going to give you some time to attempt this problem on your own. So please pause the video, and I will write down an equation to kind of help us through that. Alright, so we said that the house originally cost $20,000 in 1950. The value increased 5% each year, which seems kind of rare, but it does happen depending on the area, up to 2010. We want to find the value in 2010. So we don't know our final amount. We know that it started off at $20,000, and the rate is 0.05, and the time that's gone by is 60 years. And we know it's going to be exponential growth because it says the word increased. So I know it's going to be this equation right here, and I already set it up. I have y equals 20,000 times 1 plus 0.05 raised to the power of 60. I combine 1 and 0.05, and I get 1.05. And over here, I'm going to use my calculator, so I do 1.05 raised to the power of 60. And I'm going to multiply this by 20,000. Hit enter. It's going to cost me $373,000, or it's going to be worth $373,583. And we again have to be able to round to the nearest penny. So this is actually going to be 0.7. We round up to 2 because this 7 is greater than 5, so we round that up. So this house is now worth $373,583.72. Alright, the next thing we're going to talk about is this compound interest. And compound interest arises when interest is added to the principal, and a principal is just like our initial amount, which is P. Initial principal just means like our starting amount, so that from that moment on, the interest will be added to the years to come. So R is still rate, A is actually still our final amount, so it's going to be the amount of money that's left, T is still time, most of the time it's in years, N is the new thing, which is the number of times something is compounded. And that depends on what it is, and we're going to talk about that on the next page. So our equation is A equals P times 1 plus R over N to the NT power. And again, it's plus, so it's going to be a form of exponential growth, which is why we taught these two things together. And we need to look at some of the keywords to determine what our N value is. One of them is annually. Annual means 1. Semi-annually, just like when you go to the dentist, you should go 2 times, so it's semi-annually. Quarterly, there are 4 quarters in a dollar. Monthly, there are 12 months in a year, and weekly would be 52. If it's a daily or continuously, it'd be 365. So that way you know what your N value is when you plug that in. Okay. It says you have $1,000 you want to invest. You find a bank that offers a 5% interest rate and compounds quarterly for a savings account. First thing, I know I'm going to use compound interest because it says the word compound and it says interest. Oops. So I know that I'm going to use compound interest, which is A equals P times 1 plus R over N to the NT power. And I just have to figure out what these things mean. So I don't know what A is because that's my final amount. I'm starting off with my principal, which is $1,000, because it says you have $1,000 you want to invest. The bank is offering you a 5% interest rate, and that's our rate, which is going to be 0.05. Again, we still turn that into a decimal. So it compounds quarterly, and there are 4 quarters in a dollar, so we know that our N, how many times it compounds per year, is 4. And the time that goes on is 10. So we have all that information and we're going to plug it into our formula. So it's going to be A equals 1,000 times 1 plus 0.05 divided by 4 raised to the 4 times 10. Okay, and we're going to do most of this work on a calculator because it gets kind of messy, especially because we want the most accurate answer as we possibly can. So we go over here, clear this out. We have to follow order of operations, so I'm going to do 0.05 divided by 4. I get 0.0125. I add that to 1, and that's what's inside the parentheses. Now I go through the exponent, so I'm going to raise this to the 40th power, because 4 times 10 is 40. And again, I get this messy number, and then I'm going to multiply that by my initial amount, which is 1,000. And again, I have to round because it's money, so my final answer is that if I invest this for 10 years, it's compounded at 5% quarterly, the account is going to have $1,643.62. Alright, that's pretty much all we have for compound interest. If you have any questions, there's also a comparison one where you would just compare the two. Give it a try by yourself and email me if you have any questions. Thanks!